In this video, I'll be doing all 6 of the free response questions from the 2013 AP Calculus test. Question number 1, it says, on a certain workday, the rate in tons per hour at which unprocessed gravel travels at the gravel processing plant is modeled by g of t equals 90 plus 45 cosine of t squared over 18, where t is measured in hours. Okay, so g of t we said is in tons per hour. So it is a rate. It's kind of like a derivative already, a derivative of something. So at the beginning of the workday, at time t equals 0, the plant has 500 tons of unprocessed gravel. Okay, during the hours of during the hours of operation 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. Okay, so this is how much they're removing from the plant, and g of t is how much is coming into the plant. Okay, so part A says find g prime of 5. So if I have g prime of 5, I first need to take the derivative of g and then plug in 5. Okay, so you can take the derivative by hand. But since this is question number 1, question numbers 1 and 2 are calculator problems. So I've actually already put this into my calculator, the g function. So it's under y1, as you can see. Y2 is for the next problem, so I won't worry about it for now. We're going to do second quit. So you could actually even go to math 8, which is nderiv, put in y1, so vars, y vars, function y1, and say you want to take the derivative of x, in terms of x, at x, or t in this case, at t equals 5. So we plug in a 5, and we get that. Okay, so you don't actually need to find the derivative. It would be kind of complicated because there's a chain rule involved. But we end up getting negative 24.588. Okay, or you could say negative 24.587 if you truncate. Okay, so it says, using correct units, interpret your answer in the context of the problem. So this is a little tricky because g of t was already a rate. It was in tons per hour. So what we're talking about is tons per hour, okay? So the way that we would phrase this is we would say the rate at which the gravel is arriving it's decreasing, it's going down by 24.588 tons per hour each hour. So tons per hour at time t equals 5 hours. Okay. All right, part B. It says find the total amount of unprocessed gravel that arrives at the plant during the hours operation on this workday. So if you're arriving at the plant during the hours operation, that means you're coming from time 0 to 8, and we're just talking about what's arriving at the plant. So the arriving is our g of t dt. Okay, so again, we have this in for math, or for y1, so I'm just going to do math 9, and I'm going to integrate. So I'm going to do vars, y vars, function y1, and you might have the fancier font where it actually sets up the integral, and we're going to go from 0 to 8. Okay, so if you have the fancier one, you're just going to put it in exactly like this with g of t being y1. All right, so when we do that, we get 825.551. And that is in, since we integrated, if you think about a graph, we integrated something that was in tons per hour over a certain amount of time, hours. So if I think about the rectangles, they have a width of hours, a height of tons per hour, so we end up getting tons. All right, part C, is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5 hours? Show the work that leads to your answer. All right, so if I'm trying to figure out if the amount is increasing or decreasing, I need to compare the amount coming in to the amount going out. So I know that there's 100 tons per hour leaving, but I want to know what's happening at t equals 5, how much is coming in. So I'm going to find g of 5. So the easiest way to do that is, since it's already in for y1, go to your table. You can just plug in 5. I usually make it so I have my table set so that I can ask. So I can put in whatever I want, although 5 was already in there. So I have 98.141. And if you want to see more values, you just arrow over and you can see more decimal values, but we only need 3 decimals anyway. All right, so we have g of 5 is equal to 98.141, and this is in tons. Well, actually tons per hour. And that is less than the 100 tons per hour that is leaving. So from right there, tons per hour leaving. Okay, so since it's less than what's leaving, so we have less coming in than what's going out, what's being processed. So we can say that the amount of unprocessed gravel is decreasing at time 5. So we say it's decreasing because the amount arriving is less than the amount processed. All right, and then part D. So it says, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. So this is a difficult one, and sometimes part D questions can be pretty difficult. So if you're talking about just in general how to write the amount of unprocessed gravel at the plant, what we're talking about is we would need to say, well, we started with, so my amount at time t, we started with a total of 500 tons of unprocessed gravel. And our g of t is in tons per hour. So if I just want tons, then I'm going to have to integrate that. I'm going to have to get tons by integrating. Okay, so I'm starting out with 500, and I'm going to integrate from time 0 to time t. And it's going to be that g of, I'm just going to write it as g of x. But you have things that are leaving, right? You're losing 100 tons each hour. So we're going to go ahead and put that here. Now you could set it up as a separate integral, and you could just say minus 100t or minus 100 0 to t, like that, whatever you want to do. But basically each hour you're losing 100 tons. All right, so that's the amount that we have. Now a prime of t, right, which is how much the amount in tons per hour is changing, makes total sense. It's your g of t minus 100. It's the amount coming in minus the amount going out. Okay? Which makes sense if you just take the derivative of this. The derivative of 500 goes away. The derivative here, we would plug in t. So we'd have g of t minus 100 in there. And we get this exact same thing. So you can do it that way as well. All right. Whoops. I always do that. All right. So if I'm trying to figure out the maximum amount, every time we see the word maximum on the AP test, we know we have to take the derivative. We find where it's equal to 0, where it's undefined, and so on. So we took the derivative a prime of t, and we're going to set it equal to 0. So we have g of t is equal to 100. So we want to find when g of t is equal to 100. So I'm going to go to my graph, and I'm just going to go ahead and plug in y equals 100. And I'm going to find the intersection point. Okay, now clearly I can't see this on my graph because I had a y value of 100. So it's going to be pretty high up there. So let's at least go to a y max of like 150. And we know our time is from 0 to 8, so we can do 0 to 8 there. All right, so it's graphing the first curve, and then we're going to find the intersection point with the other curve. So I'm going to do second trace intersect, and I'm going to arrow over. With the intersection, you just have to get right on top of it. So we end up getting an x value or t value of 4.923, and I always store that. So I'm going to hit x, and I'm going to store it as alpha a. Okay, so that's in there. But on the AP test, you always need to write what equation you're solving, which we actually already have. We wrote g of t equals 100, so we're good. So we get t is equal to 4.923 something, which we're going to store as a. I usually do a dot, 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 so I know that it's going on. All right. So when we do a maximum, usually we do a number line. We put the critical value on there and we test. Now this one has endpoints as well, right? We have 0 and we have 8. Okay, so we can test a prime. And if we try like 1, we have g of 1. I don't know what g of 1 is, but you can go to your calculator and do second table 1. And then minus 100, so we still get a positive number. But then if I try something bigger than my a value, I get something less, right? Which we already talked about 5. So this one's positive still, and this one's negative, meaning we go up and then we go down. Okay, so that means that our maximum amount of unprocessed gravel occurs at 4.923. Okay, now a lot of times, like I said, they don't grade. They're not grading this chart, so we need to somehow like write this chart. So that's when I would just do like a little like t-table. And I would say, okay, for t values, I'm going to have a t value of 0. I'm going to have 4.923 something. I'm going to have 8. And I want to know what my a of t is. So we would plug into here, which is pretty easy to do with your calculator. And I went ahead and did it. And we get 500. We get 635.376. And we get 525.551. Okay? So we do get that the maximum occurs right there. So we've checked the endpoints since it is a bounded interval and so on. So we would say the maximum amount of gravel or unprocessed gravel is 635.376 tons. Now you wouldn't have to check these two if you had just written what happened, like wrote somewhere what happened in that table. So you could say a prime is greater than 0 on 0 to 4.923, a prime is less than 0 on 4.923 to 8, and that would be enough to justify that you did have a maximum there. But it's always good to check those endpoints as well. Look at the scoring for this question. You get 1 point for finding g prime of 5 correctly. You get 1 point for writing the interpretation with units. So you would have to say something like decreasing by 24.588 tons per hour, so it's kind of weird, tons per hour squared kind of, at time t equals 5. For part B, you get 1 point for having the correct integral set up. So see how simple it is? A lot of times I've told you guys that when graders look at an exam that's a 5, there's hardly anything written because they know exactly what they need to write. So it's the integral from 0 to 8 of g of t dt, so you get a point for that setup. You get a point for your answer. Part C, we get 1 point for comparing g of 5 to 100, so noticing that it's less than 100, and 1 point for your conclusion. Part D, you get 1 point for a prime of t is equal to 0, 1 point for your answer, and 1 point for justification. So like I said, you could do it with the little chart that they have drawn here, or you could do it with a number line, but you would have to write what's in that number line as well. And you always have to consider those endpoints, so you would need to see that somewhere that you've tried those endpoints. All right, question number 2. So it says a particle moves along a straight line. For time 0 to 5, the velocity of the particle is given by v of t equals that whole big long thing, and the position of the particle is given by s of t. It is known that s of 0 is equal to 10. Okay, that's our initial condition. So part A says find all values of t in the interval 2 to 4 for which the speed of the particle is 2. Okay, so if the speed is going to equal 2, that means that the absolute value of v of t has to equal 2. Okay, so we need to find that. So I've already put into my calculator, I've put my velocity function. Okay, but I haven't put absolute values around it. So I could do that. I could easily do second insert, whoops, I'm down on this one now. Second insert, math, absolute values, so go over to number, absolute value, and then I could end the parenthesis down here, like that. And then I want to get rid of these other two equations because those were from the last example. So I'm just going to deselect those equal signs. And I always try to keep all of the equations on the calculator section in my calculator just in case you have extra time and you can go back and check. So I leave them in there. All right, so I want to find when my absolute value function is equal to 2. Okay, so my window is a little bit different. I'm going to go back to my Zoom 6. I'm only on the interval 0 to 5 for my x values, my t values, right? So let's go ahead and we'll make our window 0 to 5 just in case I have an extra one and I get confused. Oh, it says find all values between 2 and 4 actually, so let's even make it smaller, 2 to 4. We're going to graph. Okay, so when we have the speed, right, it's the absolute value of the velocity. We're finding how many times it's equal to 2, and we want to find those like t values. So we're going to do second trace, intersect, and we're going to find it. So enter, enter, enter. So 3.1276. So I'm going to store that just in case. X store as A. Oops, what did I do here? All right, and then I'm going to go back in there, second trace, intersect, and I'm going to find the other one. All right, so I get 3.473. All right, so I'm going to do second quit, and I'm going to do X, and I'm going to store this one as B. All right, so I'm going to write both of those answers. So as long as I've written the equation, right, absolute value of v of t equals 2, then they know that I've solved this on my calculator. So I'm going to have t is equal to 3.128 if I round, and t is equal to 3.473. Okay? All right, B. So it says write an expression involving an integral that gives the position s of t. So if I'm using an integral for s of t, it says I want to use this expression to find the position of the particle at time t equals 5. Those ones we've done plenty of times before. We have our s of 0. We're trying to find s of 5. So what I've had you guys do in class is set it up 0 to 5, v of t dt, because we know when we integrate v of t, we get s of t, right? The position function. So we would have that. Now this one says for any time t to begin with. Okay, so it's a little bit more complicated, but it's the same idea. We still have this s of 0, which is 10. That's going to be added to the other side, right? So the best way to write this is going to be s of t equals our starting position 10 plus however it moves, right, its displacement on the first t seconds or minutes or whatever the time is in. All right, does that make sense? So if I wanted to find s of 5, I could do that setup that I just did over here. That's totally fine. S of 5 then would be 10 plus the integral 0 to 5. V of, I don't know why I did v of x dt here. V of x dx. I want to keep my variable different than the t that I had up there. So v of x, I'll just do v of x dx on this one as well. Okay. So I have my velocity function in for one of my y values on my calculator, so I'm going to use math 9. It's in, well, with that absolute value, so let's get rid of the absolute value. And I'm going to have to get rid of that last parenthesis as well. So it's in as y2. So I'm going to do math 9, vars, y vars, function, y1, or not y1, y2, darn. And my t values or x values are going from 0 to 5. So this is the total displacement after the first 5 units of time, but it was already starting at 10. So what we do is we say, oh, if we're on a number line and we're already at 10, and then we move backwards 19.207, right, I'm going to be back 9.207. Okay, so I'm going to go ahead and write this in. So I'm going to have 10 plus a negative 19.207. That's a little sloppy. So your answer is negative 9.207. Okay, and we don't know the units. It doesn't say like feet or meters or anything like that. So we're good. All right, the next one. Go to where there's more room. So it says find all times t in the interval 0 to 5 at which the particle changes direction. So when something changes direction, we need to find when v of t is equal to 0. We need to find when our velocity is positive and when it's negative. All right, so we write that. V of t is equal to 0. And we have our velocity function that's already in for y2. So we're going to go to our graph, but now we're on the interval 0 to 5. So I'm going to change my window. And I want to find where it's crossing the axis. So I want to find this point. So I'm going to do second trace. Oh, I still have that 2 in there. So I'm going to do second trace intersect, or not intersect, 0. Because I'm finding the x-intercepts. And I arrow over, it takes a little bit. And now I have to do left bound, right bound. So it's not like intersect. So left bound means I'm going to be on the left side of what I'm trying to find. So right here. Right bound means I'm going to be on the right side of what I'm trying to find. And then guess is right where I think it is. All right, so 0.536. Okay, so I'm going to hit X. And I'm going to store that, but I've already stored A and B in this problem, so I'm going to store it as alpha C. And then I'm going to do the same thing, so graph, whoops. And I'm going to do second trace 0. And I find the other one, which ends up being like 3.318. So maybe I'll just save myself some time. We won't do that. And that would be D if you stored that. So V of t is equal to 0 in 2 different locations at time, what was it, 0.536 and t equals 3.318 if I round up, or 3.317. Okay, and we want to make sure that it does change direction. Sometimes it will just kind of stop and then go back in that same direction. So I'm testing in my velocity function. So I would just go to your table and plug in numbers on each side of those. So I would try like 0.2, 3, and 4. So when you see that your velocity, which was under y2, is negative, positive, and then negative. So it means it's moving to the left or down for the first part. And you do need to, I guess, close these from 0 to 5, right? So we're going to justify our answer. So this is where you should really write what's happening in the sign chart. So we're going to say V of t is less than 0 on 0 to 0.536. And also on 3.318 to 5. And V of t is greater than 0 on 0.536 to 3.318. Therefore, the particle changes direction at t equals 0.536 and t equals 3.318. Okay, so you would have both of those as your answers. All right, and then part D. So it says, is the speed of the particle increasing or decreasing? This has been a very common one the last few years. So like we said before, if the speed is going to be increasing, we need for acceleration and velocity to have the same sign. So you don't have to write this on your test, but I'm just writing it for your reference. All right, so we need to figure out at time 4 what's happening. So I need to find the acceleration at time 4 and the velocity at time 4. Now the velocity at time 4, I actually already found right here, it is negative. So we're just worried about whether it's positive or negative. And you could go to your chart and you could find it. Now the acceleration is going to be the derivative of the velocity function, which is kind of complicated. Like, look at your velocity function. That would involve a chain rule. It would be a little bit messy, and then plugging in 4 would not be fun as well. So what we're going to do is we're going to go to our main screen, second quit, and we're going to do Math 8 and deriv, and we're going to say, okay, I want to take the derivative of that y2 function, so vars function, y-vars function, y2, and I'm going to go I'm going to find the derivative at x equals 4. So the derivative of velocity is acceleration, so that's what I'm finding. I'm finding the acceleration at 4. And I get negative 22 point something. I don't think we actually need to put that, but we will. So it's equal to negative 22.296, which is less than 0. So since they are both the same sign, the speed is increasing, right? So the speed is increasing at t equals 4 because a of 4 and v of 4 have the same sign. And then that's it. All right, so if we talk about how to grade this, for part A, you get 1 point for knowing that you needed the absolute value of v of t to equal 2, right? The speed is the absolute value of velocity, set it equal to 2, and 1 point for your answer. Part B, you get 1 point for setting up s of t, which is a little bit tricky sometimes, and then 1 point for your s of 5. For part C, you get 1 point for considering v of t is equal to 0, so you want to find those like critical places, and then 1 point for justifying that that actually does change places, so it doesn't just like stop and then go back and go in the same direction it was moving before. And then part D, you get 2 points for your conclusion with reason. So basically you would have to go through the steps where you find a of 4 and v of 4. And then you would need to say, because they have the same sign, then the speed is increasing, okay? All right, question number 3 is another chart problem. There will always be a chart problem on the AP test. These are quite popular. All right, so it says, hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t, where t is between 0 and 6, is given by the differentiable function c, where t is measured in minutes. Selected values of c of t measured in ounces are given in the table above. All right. A, use the data in the table to approximate c prime of 3.5. So if you're finding c prime is a rate. We only have c in the table, so I want to find its derivative, basically, which is the same as the slope, right? So I'm going to find the slope between 3 and 4. So these are 2 points. So it's just like in Algebra 1 when you found the slope. We're going to have 12.8 minus 11.2 all over 4 minus 3. Okay. I should probably write out my steps, though. Maybe I'll write out c of 4 minus c of 3 all over 4 minus 3, the slope, right? So when I do that, I get 1.6. Now the numerator is in ounces and the denominator is in minutes. So when I come up with that slope, the change in y over change in x will be in ounces per minute. Okay, so make sure you put the correct units. And they even say that there. All right, B, is there a time t between 2 and 4 at which c prime of t is equal to 2? Justify your answer. Okay. A question like this will usually use the mean value theorem because it's talking about is there a time on a certain interval, 2 to 4, where the derivative is equal to a certain thing? Okay, so if you remember the mean value theorem, so I'm going to write what it is, but f of b minus f of a all over b minus a, we would want our average rate of change to equal the slope somewhere. Now, writing this on your test does nothing because there is no f of x function. Okay, you would need to write this with c's. So we're going to try that. So when you find on that interval c, t goes from 2 to 4, I'm going to find c of 4 minus c of 2 all over 4 minus 2. And I'm going to see what it's equal to because it's probably going to be equal to 2, I'm guessing. So I'm going to have 12.8 minus 8.8 all over 2. So 4 over 2, which is equal to 2. Okay. That is our average rate of change. Okay. We know that we have to have a place where the slope is equal to the average rate of change as long as I have a continuous function and a differentiable function on that open interval. So I need to state that. I know it's differentiable. And then it has to be continuous because it's the rate at which, not the rate at which the coffee's cooling. I'm thinking of the wrong problem. It's the amount of water that's dripping through a coffee maker. You can't like go from, 8 ounces to 10 ounces without going through 9 ounces, right? Does that make sense? So we're going to state that just to make sure. So we're going to say C is continuous and differentiable on 2 to 4. Usually we say continuous on bracket 2 to 4 and differentiable on 2 to 4. Therefore, C prime of t equals 2 for some t in that interval 2 to 4 by the mean value theorem. Okay. All right, and in part C, it says use a midpoint sum with 3 subintervals of equal length indicated by the data in the theorem to approximate 1/6 the integral from 0 to 6 c of t dt. All right, so whenever you see this, especially with that 1/6 out front, that's like our giant red flag that this is the average value. Okay, it's the 1 over b minus a, integral from a to b f of x dx. Okay, it's finding the average value of the function. Okay, so in our problem, it's finding the average amount of coffee in the cup over that first 6 minutes, okay? So let me give myself some room. Oh, I don't have another page here. All right, so let's see. So part C. So I'm using a midpoint sum. Like I've done before, you can always draw out a sketch if you need to. It says we're using 3 subintervals, so that's nice because we had 6. Oops. We had 6 of these, right? So we're going to break it up from 0 to 2, and then 2 to 4, and then 4 to 6, okay? So I'm ignoring this value, and this value. Okay, and if I was doing a little rough sketch of what's going on, I have the point 0, 0. I have the point 2, 8.8. I have the point 4, 12.8. And I have the point 6, 14.5. Okay, so what this creates are 3 rectangles of width 2. Okay? Okay, I guess I do need those because I'm doing the midpoint. So these are actually the ones that I need, the ones that I crossed out. So I'm using these 3 as my height because as you can see, this creates the partitions, but the height of those has to be the midpoint. So I'm going to use 5.3. Let me get rid of these other numbers. So I'm going to use 5.3, 11.2, that's what that is. And I'm going to use 13.8. Okay? And all of them have a width of 2. So when I go down here, I'm going to have a midpoint with 3 subintervals, so I often write that as M3. They all have a width of 2, and I'm using those 3 values, 5.3, 11.2, and 13.8. Okay, so when I do that, I get 60.6. Now you have to be a little bit careful though, because this is not the number of ounces in a cup. That would be a huge coffee cup. Okay, we still need the 1/6. So what we're approximating is this 1/6 integral from 0 to 6 of C of t dt. And we're saying that, well, we just found the approximation for the integral part, but we need 1/6 of it. So we get 10.1. And this is the average value for C. And if you look at the units for C, it's in ounces, right? So our units are going to be ounces. All right, and then part D, the amount of coffee in the cup in ounces is modeled by this. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So now it's giving us some kind of equation to model that table that we had before. So they still mean the same thing. It's the amount of coffee in the cup, but we're getting a little bit more specific. We have an actual like continuous equation that we have. So using this model, find the rate at which the coffee is changing when t is equal to 5. So what we're going to do is we're going to find b prime of t. So b of t, let me write it up here. So b of t was 16 minus 16e to the negative 0.4t. Now this is a question number 3. Only 1 and 2 are using calculators. This is a non-calculator question. So I'm going to have negative 16, then I'm going to have e to the negative 0.4t, but I have to multiply by its chain. So the chain is going to be negative 0.4. All right, so if I'm finding this, 16 times 0.4 ends up being 6.4, so you can do that off to the side if you aren't sure. So we get 6.4 e to the negative 0.4t. And if I want b prime of 5, I plug it in. So I get 6.4 e to the negative 0.4 times 5, which is 6.4 e to the negative 2, which you can leave it like that, or 6.4 over e squared, you could write it as. And this is in ounces per something. Oops, ounces per time, and our time was in minutes. So it's ounces per minute. And you wouldn't have to find that because, I mean, you don't have your calculator. How do you find that? So we leave it how it is. Okay, so the scoring for this one, you would get 1 point for your approximation of 1.6. You get 1 point for your units, ounces per minute. So it's always important to put units. Even if you have no idea how to do the problem, if you can write the units, you get a point a lot of times. For part B, you get 1 point for recognizing, oh, I'm on the interval 2 to 4. I'm going to go ahead and find that average rate of change. So finding C of 4 minus C of 2 all over 4 minus 2 is equal to 2. And then 1 point for your conclusion saying that you've used the mean value theorem. Part C, you get 1 point for your midpoint sum, which gave you the 60.6. 1 point for your total approximation, which is 10.1 ounces. And 1 point for saying what you were finding. Okay. Oh, I don't think I actually did that. I would have missed my point, huh? Yeah, I didn't say what I was finding. So part C, it did say, using correct units, explain the meaning in the context of the problem. So you would need to say the average amount of coffee in the cup is 10.1 ounces over the first 6 minutes, or from time t equals 0 to 6 minutes. All right. And then part D, you get 1 point for setting up an equation or finding the derivative b prime of t, and 1 point for plugging in 5. Okay. All right, question number 4 has a graph with some different areas listed. It says the figure above shows the graph of f prime, so make sure you recognize that that's f prime, not f. The derivative of a twice differentiable function f on the closed interval 0 to 8. The graph of f prime has horizontal tangent lines at 1, 3, and 5. So you can see those there. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. the function f is defined for all real numbers and satisfies f of 8 is equal to 4. Okay, so that's kind of like an initial condition, it's just not f of 0. Find all values of x on the open interval 0 to 8 for which the function f has a local minimum. So whenever we see that f has a local minimum, we always want to find where f prime is equal to 0 or f prime is undefined to find the critical values. Okay, so f prime is equal to 0 in 3 different locations. Here, here, and here. Okay, not at the horizontal tangent lines because that would be the slope of f prime. That would be like f double prime. So f prime is, positive, and then it's positive again, and then positive. So you're finding where it's positive, negative, 0. All right, so if we're trying to find a local min, then we're going to put this on the number line, and we're trapped between 8 and 0. And we have a 1, 2, 3, 4, 5, 6 are my critical values, 1, 4, and 6. All right, and like I said, it's above the axis again until 4. And then between 4 and 6, we're below the axis. And between 6 and 8, we're above the axis. So what this means for f is f prime is positive means f is increasing, decreasing, and then increasing. So it asks for when f has a local minimum. So in order to have a local minimum, you would need to change from negative to positive, so it's only going to be at x equals 6. So we would need to write what's in that chart. So we would need to say f prime is less than 0 on 4 to 6, and f prime is greater than 0 on 6 to 8. Therefore, f has a local min at the x value of 6. And we don't know what that is, but we do know that it's located at x equals 6, which is all we were asking. All right, so B, determine the absolute minimum value of f on the closed intervals 0 to 8. Justify your answer. Okay, so when we talk about the local or the absolute minimum, it could occur at that 6, but it could also occur at 0. And that's because our shape is something like this. Okay, and we don't know if this point down here is lower than this point right here. So it could go up and then it could go down really far and then back up. We don't know, okay? But we know it's that sketch or a similar sketch because we have the slopes of f. We know it's positive, positive, negative, positive, right? So we need to compare. So we need to find both f of 0 and f of 6. Okay, and that's where that initial value comes into play. We were given that f of 8 is equal to 4, so we're going to use that. So if I set up the integral from 0 to 8 of f prime of x, that's going to give me f of 8 minus f of 0. Okay, and it allows me to find f of 0. And that's what we need. Okay, so looking at my graph, if I'm finding the integral from 0 to 8 of f prime of x, I'm using those areas that are listed. Okay, so if I go from 0 all the way to 8, I'm going to have positive 2, positive 6, negative 3, positive 7. Okay, that's what's represented by this integral. All right, and then f of 8, we know f of 8 was given to us, it's 4. F of 0 is what we're trying to find. So as we do that, we get 8 minus 3 is 5, plus 7 is 12. So we end up getting that f of 0 is equal to negative 8. All right, so now we want to find f of 6 and compare. So if I'm finding f of 6, I'm going to set it up the same way. I'm going to use the one that I was given, which is right here, right? So I'm going to use f of 8 is equal to 4, and I'm just going to find from 6 to 8. And I'm going to integrate f prime of x, dx. I forgot my dx over here, didn't I? And I get f of 8 minus f of 6. Okay, and what this represents is the area from 6 to 8, which is right here, which was 7. So we have 7 equals f of 8, which is 4, minus f of 6. So f of 6 ends up being negative 3. So now I compare the two. So when I compare the two, I know that the absolute minimum is going to be the lowest one, so it's going to be at negative 8. So we would need to say that. So the absolute minimum of f, let me say on the closed interval, on 0 to 8 is negative 8 at x equals 0, okay? All right, so part C, on what open intervals contained in 0 to 8 is the graph of f both concave down and increasing? So if we're going to be concave down, we need for f double prime to be less than 0. And if we're going to be increasing, we need f prime to be greater than 0, okay? So we need to figure this out. So looking at your graph, if I'm talking about f prime, remember f prime is positive here, here, and here. So from 0 to 1, 1 to 4, and 6 to 8. Now if I talk about f double prime though, let me do the chart up here. F double prime is the slope of f prime. So we have the graph of f prime. The slope of it is negative, and then it's positive, and then it's negative, and then it's positive. Okay, so we need to know where those points are that are important. So at 1, it's going to change, and then it's going to be positive until we get to 3, and then it's negative until we get to 5, and then it's positive again until we get to 8. So it goes down, up, down, up. Okay, so we're concave down, concave up, concave down, concave up. And the question is, where is it concave, both concave down and increasing? So we really kind of have to line these up so you can see. So we have 0 to 8, 1, 3, 5. Okay, and we had down, up, down, up. Okay, so we want downs and we want ups. Okay, so the places where they're overlapping would be from 0 to 1, and then from 3 to 4, right? See how there's that little bit of overlap where it was positive and then negative for the f double prime? And then from, let's see, that's it, right? So we're going to have from 0 to 1 and then also 3 to 4. So f is concave down and increasing on 3 to, well, let me write 0 to 1 first. On 0 to 1 and 3 to 4. Okay, and I think it's fine to have the justification of this. F double prime is less than 0 and f prime is greater than 0. All right, and then part D. So it says the function g is defined by g of x equals f of x cubed. If f of 3 equals negative 5 over 2, find the slope of the line tangent to the graph of g at x equals 3. So if I have g of x is equal to f of x cubed, and I need to find the tangent line, I need to find its derivative. So I'm going to have 3 f of x squared times f prime of x. Okay, and I'm asking for the slope at 3, so I'm going to have g prime of 3. So I have 3, whatever f of 3 is, squared times whatever f prime of 3. Okay, so f of 3 is pretty easy. We go up to our graph. F of 3 is going to be, well, actually, f of 3 we don't know, do we? F prime of 3 we do know. F prime of 3 is going to be 4, because that's the point on the f prime graph, 3, comma 4. So we have that. oops, not equal to 3. But we need to know what f of 3 is. Okay, and if we're finding f of 3, oh, I think I was given it, wasn't it? It's negative 5 over 2. So we're good there. You could also find it by doing the integral that we did like in part B, right? Okay, so anyway, so I end up simplifying. I get 3 times 25 over 4 times 4. The 4's cancel. So we end up getting 75. All right, so if we were scoring this problem, for part A, you would get 1 point for your answer with justification. So you would need to say at x equals 6, because we changed, f prime changes sign from negative to positive. B, you would need to show that you're considering both 0 and 6. So we found both f of 0 and f of 6. We got f of 0 was negative 8 and f of 6 was negative 3. So we compared them. The answer is that the absolute minimum occurs at negative 8. And the justification would be showing that work, showing that we compared the two places that were possibilities for the absolute min. C, for your answer, 0 to 1 and 3 to 4, and then the explanation. So you could say f prime is decreasing and positive on these intervals, or like we did, you could say f prime is, what was it? I can't remember what I was trying to find. Yeah, f prime is positive and f double prime is negative for the concave down and increasing. And then D, g prime of x, you get 2 points for taking the derivative correctly, remembering that you have a chain, right? You multiply by f prime of x, and 1 point for the answer, which was 75. All right, question number 5. So we have f of x equals 2x squared minus 6x plus 4, and g of x is equal to 4 times cosine of 1/4 pi x. Let R be the region bounded by the graphs, as shown in the figure. So find the area. So when we're finding the area, we need to know what x values we go from. And it's pretty easy to see. It does from 0 to 2. That was very nice of them. This is a non-calculator one, so it's going to be a little bit easier than some of the ones you've done before. But it still involves some pre-calc skills. All right, we need to decide which one's f of x and which one's g of x. And you can do this a couple different ways. You could maybe plug in 1 and see where each one would be located. Or you can just use your knowledge of graphs and know that this is an upwards parabola, and that cosine graphs typically start at like 0, 1. So if you have 4 cosine of 1/4 pi x, it's going to start up at a height of 4. So that means that your f of x is this one, and your g of x is this one. So when I find the area, I'm going to do the top, which was g of x, minus the bottom, which is f of x. And I'm going to integrate. Okay, and this is all by hand. So I'm going to write this as pi over 4x. All right, so when I integrate, if I have 4 cosine of pi over 4x, it's a u substitution. You would let u equal pi over 4x. So du then would be pi over 4 dx. So you would end up gaining a 4 over pi on the other side. So dx is going to be replaced by 4 over pi. So I'm breaking up these into 2 integrals, by the way. All right, so I'm going to have the 4, and I'm going to have a 4 over pi. The integral of cosine is going to be sine of pi over 4x. And I'm going to go from 0 to 2. Now the other one ends up being minus. And when I integrate, I get 2/3 x cubed minus 3x squared plus 4x. Okay. So it's a lot to find by hand. It's challenging. So we have 16 over pi. I know you guys get used to that math 9. You just want to use your math 9 all the time. Okay, I'm not going to worry about the 16 over pi. I'm going to find sine of 2 pi over 4, so in other words, pi over 2, minus sine of 0. And I'm going to do minus. And I'm going to have my 2/3 times 8, right, 2 cubed, minus 3 times 4 plus 4 times 2 is 8. And all of that's going to be minus 0, so that's lucky at least. So sine of 0 is 0, so that's out. This is gone. All right, so I have 16 over pi times 1, right? Sine of pi over 2 is 1, minus 16/3, distribute my negative, so plus 12 minus 8. So 16 over pi minus 16 over 3 plus 4, which is going to be 12 over 3. So 16 over pi minus 4 over 3 should be the answer. Long one, right? Now, luckily, the next one says write but do not evaluate, as does letter C. So that's always nice. So B. So it says write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 4. Okay, so here's the line y equals 4, and we're rotating around it. So since this is like an x-axis line, we're going to integrate everything in terms of x, right? We're going to have dx. We're going to use the distant washer method. So this is like our shaded region. So if I come up with my outer radius and my inner radius, right? The outer starts from my axis of rotation, which was 4, and I want to know this distance there. Okay, so just like if I have, the distance between 10 and -3, I would do 10 minus a -3. Or between 10 and 2, I would do 10 minus 2. Right? That's what I'm doing. I'm doing the top minus the bottom. So r equals 4 minus the bottom curve, which is f of x. And little r, my inner radius, ends up being 4 minus my inner curve, which is g of x. Okay, and I just have to be kind of careful because I called it region r, so I'm going to call it r1. And as long as you've written that somewhere, you can just set it up as that. So you're going to say your volume is equal to pi. You go from the x value 0 to 2. You have your outer radius squared minus your inner radius squared. And everything's in terms of x. So if you wanted to actually put in the equations, you would have pi 0 to 2, 4 minus f of x squared minus 4 minus g of x squared dx. So you could write it like that as well. All right, and then C, the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis. So whenever I say perpendicular to the x-axis for these ones, it means I'm making all my chops like this. So my x is changing, so I'm integrating with respect to x. So whenever you see that, integrate with respect to x. And these are going to be squares. So imagine you have like a 3D picture, and you have, let me kind of draw it slanted, you have these little squares coming up off of it, okay? So these squares have a length and a width, and they're the same thing. So we want to know how to represent this distance from the top to the bottom. Okay, and what that ends up being is just f of x minus, well, hang on, g of x minus f of x, right? This was our g of x curve. So we're going to have our volume. We don't put a pi because we're finding the cross-section area, and we're integrating that cross-section area. So the area of the square is going to be g of x minus f of x. That's one of the sides, so I square it, right side squared. And my x values go from 0 to 2 still. Okay, so that would be the setup for that one. And you can leave it like that. I never put in like f of x and g of x because it's just kind of time consuming, and if you miss a negative sign or something, like you don't want to get it counted wrong. But at least you have the correct setup right there. Okay, so the scoring for this one. For part A, you would have 1 point for the integrand. The integrand is this g of x minus f of x. 1 point for the antiderivative. So for, let me underline the part, this and this, and then 1 point for your answer, okay? For B, you would get 2 points for your integrand. So this whole part right here, 2 points probably for each part of that. 1 point for the limits and constants. So the limits of integration are the 0 to 2, and the constant is pi. So 1 point for having both of those. All right, for C, you would get 1 point for the integrand, so this inside part with the squared, 1 point for the limits, and I don't know why they said limits and constant for this, just the limits, 0 to 2. There's no constant out front this time. Okay, so let's try the next one. So the very last problem of the 2013 test, it says consider the differential equation. Let y equal f of x be the particular solution through the point 1, 0. So that's our initial value. Okay, part A has nothing to do with solving a differential equation. It says write an equation for the line tangent, which whenever we have that, we know we need to find the slope and a point. So if we're finding the line tangent to f at the point 1, 0, my slope is going to be f prime of 1. Okay? In other words, I'm looking at my dy over dx, and I'm plugging in 1 for my x's and 0 for my y's, right? X, y. So I'm going to have e to the 0, 3 times 1 squared, minus 6 times 1. So I get 1, 3 minus 6, I get a negative 3. The point is just the point that we were given. The point is 1, 0. So my equation of the tangent line is going to be y minus y1 equals m times x minus x1. Just like in Algebra 2. You can simplify if you want to, or you can leave it like that. Now in this case, it's pretty easy, right? It was y minus 0 anyway. So if I'm finding f of 1.2, I'm going to use that equation of the tangent line. So as long as 1.2 is close to my x value, 1, we're good, right? It's kind of like saying if you zoom in close enough to some kind of curve, when you zoom in, it looks like a line. That's what we're saying. Okay, so we find the equation of the tangent line and we use it to approximate. So f of 1.2 is going to be negative 3 times 1.2 plus 3. So I get negative 3.6 plus 3, which is negative 0.6. All right, and then part B, that's our separable differential equation. We've practiced these a lot in class. So I'm going to start out with the original, which was dy over dx equals e to the y times 3x squared minus 6x. And I'm going to separate my variables. So I want my 3x squared minus 6x to go with the dx. And I'm going to have 1 over e to the y dy. This is not, when you integrate, it is not going to be a natural log. So a lot of people assume that when you have a 1 over, they think it's going to be like natural log of the absolute value of e to the y. It is not that. Do not do that. So don't assume everything that has 1 over is going to be natural log. For example, 1 over x squared, right? We write it as x to the negative 2, and then we integrate by adding 1 to the power, and so on. So what we're going to do here is we're going to rewrite as e to the negative y dy. And on the right side, we can go ahead and integrate. So I get x cubed minus 3x squared plus c. So this is a u substitution. You probably don't need to do the u substitution, right? So our u is equal to negative y. So du then becomes negative 1 dy. So I get negative 1 du equals dy. So basically what's going to happen is you're going to gain a negative when you integrate. So you're going to have negative e to the negative y, which makes sense because take the derivative of it and you get e to the negative y, right? Okay, and our point is 1, 0, so I'm going to plug in 1 for x, and I'm going to have 0 for y. So I get negative 1 equals 1 minus 3 plus c. So negative 1 equals negative 2 plus c. So c equals 1. And then I go back here, and I plug in. So I have negative e to the negative y equals x cubed minus 3x squared plus c. But my c is now replaced by 1. And I try to solve. Okay, so it's a little complicated. First, I'm going to get rid of that negative out front. So I'm going to have negative x cubed plus 3x squared minus 1 equals e to the negative y. In other words, it's 1 over e to the y. So when I have a 1 over something with y, what I do is I end up taking the reciprocal of both sides. Okay, so you can do that, or You could also keep it like this and then just take the natural log of both sides. It's up to you. It's whatever you want to do. So I'll do the natural log of both sides. So I get negative y equals natural log of negative x cubed plus 3x squared minus 1. And then I'm going to divide by a negative 1. So I'm going to get a negative natural log of negative x cubed plus 3x squared minus 1. Now, if you had done the reciprocal thing, you would get an equivalent answer. It would just look very different, okay? What would happen is this negative would have basically gone up to the top, and your answer would look like this, which the AP graders would also grade. So there's more than one way to do these problems. So don't think just because your answer might be different than someone in the classes as you're practicing, like that your answer's wrong. It may not be wrong, right? All right, and then the last thing we usually say is if we have some kind of weird, we have natural log of that, we know it can't be negative and it can't be 0. So we would always just say negative x cubed plus 3x squared minus 1 has to be greater than 0. And sometimes the domain, as you know, is much nicer. It'll be like x is greater than 2. But in this case, don't waste time like solving for that. They didn't ask for the domain in part B, so they probably don't care, but it's just making sure that you still have it. All right, so scoring. So you get 1 point for finding dy over dx at the point 1, 0. So you're getting negative 3. You get 1 point for the tangent line equation and 1 point for the approximation of negative 0.6. For your separation of variables, you have to do it, otherwise you get 0 points. We've talked about that before. So we separated the variables, which is this step. We found an antiderivative, there's 2 more points. We knew to add a plus c. We knew to plug in the 0 and the 1, and then we knew how to solve all the way down for y. That gets the last point. Okay? Again, it says max of 3 out of 6 if you have no constant of integration. So if you don't include that plus c, there's no way that you're going to get the y equals equation correct. Okay? So you would only get 3 points then. All right.